2.6 talks about the combination of functions and composite functions. And so in day 1, we're going to talk about the domain of a function, and we're going to combine functions using the algebra function specifying domains. Alright, so it says defining a function's domain. If a function f does not model data or verbal conditions, its domain is the largest set of real numbers for which the value of f of x is a real number. Exclude from a function's domain real numbers that cause division by 0 and real numbers that result in an even root, such as the square root of a negative number. Alright, so what it's telling us here is that our domain is going to be all real numbers unless we have certain restrictions here. So domain is always all real numbers which we show as negative infinity to infinity unless. Now, it has to have one of these restrictions not to be negative infinity to infinity. The first one is if we have a fraction with x in the denominator. Okay, because remember with a fraction, our denominator cannot equal 0. And so, for example, if I have 1 over x plus 2, then we know that the denominator, the x plus 2, cannot equal 0. So we'd solve for x. And so x cannot equal negative 2. So to actually find our domain then, I'm going to take and put that on a number line. So negative infinity to infinity. We'll put that number negative 2 there. But remember, it can't equal negative 2, which means it can equal everything to the left and everything to the right of it. And so we can see right there, there's our intervals. So the first one is negative infinity to negative 2, and we're going to use parentheses, union negative 2 to positive infinity using parentheses. Now we use parentheses on the infinities because remember we can never touch infinity, and we use parentheses on the negative 2 because it's not equal to, and parentheses means not included, not equal to. Alright, and the other restriction there is if it's an even root radical, such as a square root, 4th root, 6th root, 10th root, something like that. So if you end up with an even root radical and it has x underneath it, you're going to take the square root of it and you're going to set it greater than or equal to 0. So if I have the square root of x plus 7 and then minus 2 out here, we can tell that it's not a fraction, but we do have an even root radical in it. Well, we don't have to worry about the minus 2. It's not in that radical, but we're going to set that radical greater than or equal to 0, and then we're going to solve. So let's square it. So x plus 7 is greater than or equal to 0. Subtract the 7. And so we know x has to be greater than or equal to negative 7. So again, I'm going to use a number line to kind of guide me. Let's put my infinities on there. See, we got our negative 7. And it says x is greater than or equal to. So greater than is to the right. And so I can see here that my interval is going to start at negative 7 with a bracket because it's equal to. And it's going to keep going all the way to that positive infinity. Infinities are always parentheses. And so there's the domain for that. Now, the one other you want to have to be careful of is what if it combines the two of these together, okay? These are only two restrictions. Either if it's a fraction with x underneath it, if x in the denominator, then it's not negative infinity to infinity. If you have an even root radical, it's not negative infinity to infinity. But sometimes you will see that they will have them together. So they might have something like 1 over the square root of x plus 4. Now let's do minus 4. Okay. The fact that we see there's a radical, then we know the square root of x minus 4 has to be greater than or equal to 0. But we also see it's in the denominator of that fraction, which means the denominator cannot equal 0. Now when you put these two restrictions together, notice the first one says greater than or equal to, and then the second one says can't be equal to, okay? So when you put it together, you just end up with the square root of x minus 4 is greater than 0. It can't be equal to the 0 because it's on the bottom of the fraction. And then you would just go ahead and solve this. So you get x minus 4 is greater than 0. Add the 4. X is greater than 4. So if I use my number line to guide me at the 4, and it's going to be an open circle because it's not equal to, greater than is to the right. And so we can see that it is from 4, I didn't put my infinities here. So from 4 to infinity, infinity's a parenthesis, and the 4 is not equal to, so it'll also get a parenthesis. So this would be our domain on that. So just watch out for it if they put them both together. Alright, so find the domain of the function g of x equals 5x over x squared minus 49. Well, is it negative infinity to infinity? Well, let's check our restrictions. The first restriction is if it's a fraction. It's a fraction. So it's not going to be negative infinity to infinity. But because there is a fraction, remember we said we're going to set our denominator not equal to 0. So my denominator here is at x squared minus 49. Now we have two ways we can solve this. We can factor it out because it's a difference of squares, or we can use our square root property. I'll show you both of them. So if I use the square root property, which is the easiest one probably for most of you, but it's also the one you're going to make the silliest mistake on. So you get x squared cannot equal positive 49 when you move the 49 over. And then when you take the square root, you'll get x cannot equal. Remember, when you take the square root of a number, you get plus or minus, and the square root of 49 is 7. Don't forget, because we started out with an x squared there, we should have two answers, okay? A lot of y'all forget the plus or minus. If I had factored it, I would start out the same way. Remember, factoring the difference of squares says if you have the two numbers that are perfect squares, you can take their square roots and rewrite it as a plus b times a minus b. Alright, so we're going to take the square root of x squared, which is x, the square root of 49, which is 7. There's my a and b. So I'd write it as x plus 7 times x minus 7. Cannot equal 0. And then we know because two or more things are being multiplied together, and they were set, we said before they were set equal to 0, now it's just not equal to, no big deal. Then we can set them individually, not equal to 0. So x plus 7 cannot equal 0, x minus 7 cannot equal 0, and then solve them both. And so we'd get x cannot equal 7, and we get x cannot equal negative 7. So either way we do it, whether we use the square root property or we factor it and use our difference of squares, we still got x cannot equal positive or negative 7. So to actually write out our domain, oops. Okay, I'm going to draw my number line here to guide me. I'm going to have the negative 7 and the positive 7 up here. Make sure they're written in numerical order. We know it cannot equal them, but it can equal everything else. And so we can see our intervals. First one is from negative infinity up to that negative 7. And then negative 7 up to that positive 7, and put a little union symbol between them. And then we had from 7 on to positive infinity. And so this would be our domain. Now, it says let f and g be two functions. We can find the sum, the difference, the product, and the quotient of these functions. So the big thing here is just watch out for your notation, okay? So it says the sum is f plus g with respect to x. It means we're going to take our f of function, we're going to take and add it to our g function, and this is just notation, guys. X is just our variable, okay? Which means the same thing as we're going to take f of x and g of x, and we're going to add them together. Sometimes you'll even see them write it. They're a little lazy sometimes, and they'll even say, what is f plus g? They don't even put that x is a variable, okay? So it all means the same thing. Same thing if it says to find the difference, and we're just going to subtract them. Product, we multiply them. The quotient, we're going to divide them, but we got to be careful because we got to remember whatever the denominator is before we reduce it cannot equal 0. All right, so example 2 here says let f of x equal x minus 5 and g of x equal x squared minus 1. Find each of the following. So the first one here, we're looking for f plus g with respect to x. So that means we're going to take f of x and we're going to add g of x. And so when I add and subtract and multiply even, I just put my f of x and my g of x each in their own parenthesis. So let's see, f of x was x minus 5, and it says plus, and then g of x was x squared minus 1. So first thing we want to do is get rid of the parentheses. So go ahead and distribute the sign there in the middle. So we get x minus 5. Remember, it's like a positive 1, so 1 times x squared is x squared, and 1 times negative 1 is negative 1. Once you do that, you want to combine like terms, and you want to put it in descending order of the exponents, meaning largest exponent first, and then going down. So I have a positive x squared, then I have a positive x, and then I have like terms here. Negative 5 minus 1 is negative 6. Now, it didn't ask me about it here, but I'm going to go ahead and talk about it. What about its domain? Well, let's see. Remember, our domain is all real numbers and less. Is this one a fraction? No, the answer is not a fraction. Is it an even? Does it have an even root radical? Does it have a square root, a fourth root? No, it does not. So therefore, my domain is at negative infinity to infinity. It has no restrictions in it. All right, B says let's multiply them. So we're going to take f times g with respect to x, which means we're just going to take f of x, and we're going to multiply that times g of x. So let's see, f of x is x minus 5. I'll move that over a little bit to the right here, or to the left here. So x minus 5 times g of x, which is x squared minus 1. How do we multiply with binomials? Well, remember, if it's more than one term, we're going to use our box. All right, so I have 2 terms times 2 terms. So I need a 2 by 2 box. One of them goes across the top, so I'm going to put my x minus 5, the other one down the side, so x squared minus 1. And then we multiply. Going across, we get x squared times x, which is x cubed, and then x squared times a negative 5, which is negative 5x squared. Okay, going across in the second row, I get negative 1 times that x, it's negative x, and then negative 1 times the negative 5, which is positive 5. Then let's pull them out of that. So we've got our x cubed. We don't have any like terms, so I'm just going to go ahead and write them in descending order. So then I have a minus 5x squared, minus x, and a plus 5. They're in descending order. I have no like terms. This is my answer. And again, just for grins and giggles, let's talk about the domain. To get your answer. Does it have one of the restrictions? Does it have a fraction in it? It does not. Does it have an even root radical? It does not. So therefore, our domain for this one is negative infinity to infinity. And let's go ahead and skip. Let's do D real quick. So D says g minus f with respect to x. So just remember that means we're going to take g of x and we're going to subtract f of x. Well, it's just like A, except for they're switched around because g is first and there's a minus sign between them. So let's see, g of x is x squared minus 1, minus f of x is x minus 5. Okay, so we're going to distribute the minus sign there. So remember, it's like a negative 1. So bring down your x squared minus 1. Negative 1 times x is negative x. Negative 1 times negative 5 is a positive 5. Then we combine like terms, and we write them in descending order. So our largest is x squared. Then we have a minus x. And then we have the like terms of negative 1 plus 5, which is positive 4. All right, and if we look at our domain, does it have a fraction? Our answer, it does not. Does it have an even root radical in it? Does it have a square root or something like that? It does not. So therefore, our domain, again, is negative infinity to infinity. And then let's go do C. C says we're going to take f of x and we're going to divide it by g of x. All right, so f of x is the x minus 5. G of x is the x squared minus 1. Well, the only thing we can do here is if we could factor, we might be able to cancel something out. I can't factor the top, it's just an x minus 5. over the denominator, I can factor. This is like that domain we looked at in example 1. It's a difference of squares. The square root of x squared is x. The square root of 1 is 1. So when we factor it, we get x plus 1, and we get x minus 1. Now, of course, nothing's going to cancel there. But remember, if we'd have had an x minus 5 on top and bottom, then they would have canceled. All right, so this could be our answer, but they're probably going to go back, since this is multiple choice, and say that's going to be our answer, okay? They usually use it in simplified form. Now, when we go to do the domain for this one, the domain is what our denominator was before we did any canceling, okay? Our domain here is going to be where g of x cannot equal 0. Remember, it was specific on it. Because g of x is our denominator, it cannot equal 0. When we do that, that's that x squared minus 1 cannot equal 0. And we can use the square root property, or we can factor it. We just factored it a minute ago. So if you wanted to use the factors, you could, or I'm going to go and practice the square root property again. So I'd add 1 to it. And so we get x squared cannot equal 1. Take the square root, and so x cannot equal plus or minus 1. If you do a number line here to help you on this one. So put your infinities, put your -1 and your +1. And remember, they can't equal that, which means it equal to everything except them. And so you can see your intervals right here. So you know that your domain is -infinity to -1 union, -1 to +1 union, and then 1 to infinity. And so that would be our domain. All right, moving on there. So you can see here it asks us about the domain of A and of C, which we just found. So instead of redoing it, and I did it because we could actually see what our answers were. So we're going to say C example A. And here we're going to say C example C. Okay, because the same example is just a different piece of it. So C example A, C example C, because we already did those. All right, and so that is the end of day 1.